back, everybody. Next up is Rainer Stropek with Rust and WebAssembly. So everybody, please give us a few clapping hands into the chat, and the word goes to Rainer.
Thank you very much. Thank you for the nice introduction, and thank you for having me here at Karlsruhe JS. I'm really glad to be here. I was invited to talk a little bit about Rust and JavaScript, Rust and WebAssembly, how these two things go together. And I'm looking forward to 30 minutes of Rust, WebAssembly, and TypeScript. I promised you that this will be a talk for everybody, including those of you who do not know Rust so far. So if you are a Rust beginner and you are just curious how this language feels, you will get a glimpse of Rust in this talk. So it's not just about WebAssembly and TypeScript. Second, I promised you a talk without any slides. I promised that I will do code only, and this is exactly what we are going to do. For this talk, I created a brand new sample, and what could that sample be about currently? It has to be about something in the Wordle, Nerdle, Mathler universe. Yes, we are going to do a puzzle, a number guessing or a formula expression guessing puzzle similar to Mathler or Nerdle or things like that. And I'm pretty sure that many of you know the principle. Let me quickly show you what this is all about. And thank you for bringing my screen up. Here you see how this Nerdle thing will look like. Nerdle works in this way, or it's more Mathler. Maybe you have ever played this game. Have you ever played? If not, try it. It's a lot of fun. You get a result, as you can see it here, and then you have to guess a mathematical formula that results in this number. And then you will get some color indicators. Black means this number or operator doesn't appear in your formula. Yellow means this appears in the resulting formula, but on a different space. Green means that this is the correct number or correct operator at the correct space. And this is exactly what we are going to do. Now, it would be easy to implement that in TypeScript, of course, but the sweet spot of Rust and WebAssembly comes in where it comes to number crunching. And in my case, I am simulating this problem space by distributing the work in the following way. In Rust, in WebAssembly, we are going to generate the expression that the user has to guess. So this is a little bit of number crunching, not very complicated, but I only have 30 minutes. So it is an example, granted, but still it is a little bit complicated business logic. So we have to do some loops and conditions and things like that. And the user interface, this is the domain of TypeScript and the browser. And this is where TypeScript comes in. And I'm going to show you how we will consume the Rust code inside of TypeScript. This is exactly what we are going to build. Now, if you would like to follow along, or if you would like to try the example at home and dive deeper into some of the things that I'm going to show you, the whole code is online. I already posted the URL, and I think it's currently, you see it currently in YouTube. The code is online. I created a bit.ly link for you, and here you also see the link. Here it is. It's on GitHub. Just go there, and here I have my script for today's talk. It's written in a kind of hands-on lab style, so you just have to follow step by step by step, and then you can recreate the entire sample that I created for this meetup today. Okay. Without any further ado, let's get right into the topic and let's get right started. The first thing, we have to set up a new project. And in Rust, you have a neat little tool which is called Cargo. Cargo is like NPM for TypeScript and JavaScript, but for Rust. And with that, we are creating a new project. Cargo new Nerdle, I called it Nerdle, and it's type of library. If you want to build a WebAssembly thing that you can consume from JavaScript or TypeScript, you have to create a Rust library. And this is what we did. Let me go into that folder and spin up Visual Studio Code. It opened on the wrong monitor, and now it's on the correct monitor. And don't worry, I will zoom in so that you will see the code that I'm going to write. Now, let me quickly tell you a little bit about this project. This is a typical Rust project. I zoom in a little bit. The Cargo.toml file it is similar to what you know from package.json. It contains the dependencies, some metadata, and so on. The cargo log file is like the package log.json file. Git ignore, I don't have to talk about that. Source is where our source code lives, and target it is what you might know as JavaScript developers as dist. And in Rust, it's called target. So the first thing that we are going to do, we are going to set up, as you can see here, we are going to set up our dependencies. And unfortunately, I really have very limited time today, so I will just copy in all the dependencies that we are going to need in one go, and I will only show you some of the things that are really important here. This is the metadata, just like package.json, but this is not JSON. This is Tom's obvious markup language, TOML, and yeah, it is like it is. We are creating a library. This is relevant and necessary for creating a WebAssembly library. And here we have the dependencies. And the most important dependency is this one. Please remember it, Wasm bind gen, because this is where the binding generator lives. The binding generator, which creates bindings from Rust to WebAssembly and then also to JavaScript and TypeScript. So this is the magic tool. This is Harry Potter. This is the fairy dust that we spread across, that is sprinkle across our Rust code, and it will generate WebAssembly and all the necessary JavaScript and TypeScript helper code that you will see in a second. What else do we have here? This one is nice because then we get so-called panics, exceptions in Rust directly in the browser's console. It's just a helper thingy here. SERDI stands for serialization and deserialization. It's the serializer and deserializer from Rust. Rand and getRandom are just random number generators, and in this case, we are using a random number generator that can reuse the random number generator that is built in the browser. Last but not least, we have some def dependencies that we are going to use within our unit tests. Yes, you heard correctly. We are going to implement unit tests for our Nerdle, and we will run the unit tests in WebAssembly outside of the browser. So you see everything in Node.js. So we will write unit tests and run them in Node, and they will make sure that our code really works. And the last one, you will see it later on. It's similar to what you know in JavaScript as eval. Yeah, it's the thing where you throw in an expression and it will calculate the result. This is a helper library that we will just use for the purpose of testing. So this is just the testing stuff. This is cargo log in a nutshell, if you want. And with that, we are perfectly fine, and we can go directly into the source code. Here we have the source code, and currently the source code only consists of some tests, and we are going to delete that immediately. So let's set up the first lines of Rust code, okay? So let me open it here on my right-hand monitor, and I'm going to copy in some code, and this will just be some setup code which is necessary. So what you see here is some so-called use statements. They are just like import statements in TypeScript or requires in JavaScript. Very similar. This is just the syntax as it is in Rust. Don't worry about the warnings here. They are just telling us that we are currently not using all these use statements, so the warnings will go away once we finish our sample application. The next thing jumps directly into our main topic, because this is really interesting. As you can see here, we have our log function, and guess what? This is the console.log. This is an external function, and Wasm bind gen is capable of making all the JavaScript goodness available from Rust. So whatever you implement in JavaScript, if you have any JavaScript global method, you can directly import it here. It can be a built-in function like console log or alert, but it can also be a custom function that you wrote. So the direction call a JavaScript method from Rust works perfectly fine, and this is exactly how you do it. Not very complicated. For those of you who are new to Rust, you might wonder what this here is. Let's use a different color here. This is a macro. This is a macro. If you have ever written C or C++ code, you might have nightmares from macros, but believe me, this is not your grandparents' C macros. This is a brand new way of macros. In Rust, macros are really huge. You use them all over and over. They are there to make your life easier. Rust is not the easiest thing on earth, but macros make the complexity go away. It's just, as I said, some Harry Potter programming, a little bit of fairy dust, and everything else will be generated out of the box. Macros are a huge thing in Rust. You can take that away from this talk. Okay, nice. So we have the external dependencies, and we can fold up this code region to focus on what we are really going to do. The next thing is we need an initialization function just to get started. Yeah, we are just warming up. Okay, I want to show you some warm-up stuff. Now this one is a function, as you can see it here, and again we have wasm bindgen macro on top of it. So this is the way how you can make a Rust function callable from JavaScript or TypeScript. So whenever you decorate something with the wasm bindgen macro, then wasm bindgen will generate the necessary WebAssembly binding JavaScript code and TypeScript code to make this function easily available from JavaScript and TypeScript. And in this case, we are setting or initializing the console arrow panic hook to make sure that any kind of panic unhandled exception is displayed properly in the browser's console. If you really want to shrink down your WebAssembly to the absolute minimum, of course, you are going to avoid panicking at all because that is code at the end of the day. But this is a sample environment, and it really doesn't matter if our WebAssembly is, I don't know, 20 kilobytes or 18 kilobytes. It really doesn't matter. So I put it in, make it nice. And here you see now everything coming together because this function will be called by JavaScript. And with this function, we will call back into console log and display something in the browser log. So this is where JavaScript comes in, and this is where we call back to JavaScript. And in this case, we are going to take a string, as you can see it here, inclusive UTF-8 characters, emojis. Every talk needs emojis, right? And we are going to print something on the screen, okay? And this is the first things that I wanted to show to you. Okay, nice. Let's fold up this region and we can get started a little bit more. I am going to copy in some additional code, and this is especially interesting for those of you who have never seen Rust before, because you are going to see some interesting things about Rust. First, let me zoom in here a little bit. What you see here first is a so-called enum. You might know enums from other languages like TypeScript or C# and things like that. And you might think that you know enums, but believe me, enums in Rust are completely different beasts. Enums are similar to structs, but they are even more powerful than structs. In 30 minutes, I cannot go into all the details. I cannot give you a full overview, but just trust me with this. You will see a little bit that in the upcoming minutes. But enums are a whole universe on their own, and we could talk for hours about them. It's not the enums that you know from TypeScript. We are not going to talk about the derive macro up here. It just auto-implements code with which we can copy and clone an operator. In this case, the operator is just a byte indicating the operator that we generate in our code puzzle. But the next lines of code, if you take a look at that one, for instance, then you already get an idea how powerful enums are, because this is again an enum, but now we can implement a so-called trait. A trait is similar to an interface in TypeScript, but way more powerful. So interfaces know a little bit and traits know way more. Again, we can talk for days about how traits work. Traits are essentially what make Rust an object-oriented language. You have polymorphism, you have monomorphization, and things like that. A lot of stuff. You can have dynamic method dispatching, you can have static method dispatching, you can have generics, and many, many other things. And here we are implementing a so-called system trait display for our enum. The system trait display is used whenever we want to turn an operator into an end-user friendly string representation. So in this case, we are using a so-called match statement, and this match statement turns our operators into characters. And this is exactly what we do here. We are turning our internal enum into an end-user friendly string representation. But the point is, we have an enum and we implement an interface, trait in Rust lingo, we implement the trait for this enum. This is pretty powerful, and you probably can't do that in a lot of languages because enums are completely separate from classes or structs. But in Rust, that's perfectly fine. And in the same ballpark is this thing here, implement operator. Here we can add functions to enums. So in this case, I add 3 functions. The first one is muldiv. Is it multiplication or division? It's pretty simple. It uses pattern matching here. Self indicates that this is an instance method. So you need an operator in order to call this method. It's not a static member. It's an instance member. This is the second method. It's pretty obvious, isn't it? And the third one is, again, very interesting. And we have to take a little bit of a look here. The third one is a calculate method. Calculate means that we take the given operator stored in self. We have a left operand, we have a right operand, and then we calculate the result by either doing the multiplication, the addition, and the subtraction. And the division is a little bit more complicated because in our game we have a rule. And this rule says whenever we do a division inside of the expression, it must not have a remainder different from 0. So we can't add 5 divided by 3. That is not possible because 5 cannot be divided by 3 without a remainder. We can have 6 divided by 3 because 6 divided by 3 is 2 with no remainder. Get the idea? This is the business logic that we do here. And the reason why I did that like that is this one. This is the star of the show here, result. This is how you indicate the result, an error or success in Rust. In JavaScript, you would probably return either a Boolean if you have a method like try something, or you would throw an exception. Exceptions do not exist in Rust. It is not a good practice to return a Boolean. The good practice is to return a result. And result, guess what? It's an enum again. An enum with 2 possibilities. Either OK, then we can pass in a result, or error, and then we can optionally add additional error information here. I will not go into that details because I only have 30 minutes. So in this case, we are just indicating there was an error. Okay? This is what we do here. And guess what? If we call this method from JavaScript, then the Wasm bindgen will auto-generate JavaScript code which understands result, and if result results in error, then it will automatically throw an exception in JavaScript. So the Wasm bindgen infrastructure does not just stupidly allow us to call, but it also understands the most basic principles of the languages, and it can translate these things. Result is translated into an exception. There is another very famous enum, which is called option. Can be either none, it's like null, or undefined in JavaScript, and some, which is really a value. It's Rust's representation of a null pointer. And guess what? If you return option, then in TypeScript, you will get an optional data type. And it will be automatically translated into null or undefined. I think you get the idea. Okay? These are these methods. Good. I like that. Everything is okay. And we can start the next topic. The next topic, now we have written a little bit of code, is obviously some testing. Because hey, we are good developers, and therefore, if we write non-trivial business logic, we are going to write some tests. And this is how you write tests. As you can see it here, you can put the tests directly into the same Rust file, as you can see it here, or you can also put them in separate files if you want. You can also create a separate folder, which is called test. As a sibling to source, you can call test, and in this tests folder you have some integration tests, for instance. So it's up to you if you want to have it inside of the file, in a separate file, or even in a separate folder, depending on your needs. And in this case, I'm testing the display functionality by, as you can see it here, formatting the plus operator and checking with assert equal whether the result is a plus. The exclamation mark here indicates again a macro. Assert equal is in reality a macro again. Now this tries to do a correct calculation. 1 plus 2 is 3 with an OK. 4 divided by 2 is an OK of 2. But if we try to divide 5 by 2, it would result in a result with a remainder, and therefore it has to be an error. So these are the tests that we did so far. Okay, so I think it is now time to give it a try and test it. Let's do that. We can use Webpack. This is the tooling. It sits on top of Cargo, and it does everything we need for working with WebAssembly. And in this case, we are going to test, and we are going to run the test in Node. You could also run your tests inside of the browser, but I don't have the time to go into the details. But I'm pretty sure you will find out the details by just Googling it. So let me run this guy here. As you can see, everything is compiled. It takes a while because we just created this application, and the next time we call this thing, everything is okay. We still have some warnings because we don't use some of the things, but the important thing is here. As you can see here, we compiled our Rust code to WebAssembly. Then we spun up Node.js. In Node.js, automatically our WebAssembly has been loaded and our unit tests were executed. And as you can see, 3 passed. In order to show you that this really worked, I will mess it up here and I will rerun my tests, and obviously it will not work. As you can see here, OK2, OK3 doesn't work as expected. So it isn't a fake, it's really doing what I promised to you. Okay, nice. Now we have the operator logic. It worked as expected, so we can fold this one up. Fold up the tests. We will come to them later on, and I will again copy in a little bit of code. This will be the last section of code that I'm going to copy in, and afterwards we are going to take a look at a little bit of TypeScript. Now let me grab this code. Here it is. Here it is. And this code is now generating. Oh, I forgot to copy a little bit above. Give me a second. Bear with me. And here we are. Now we are good. Now, this code is really the heart of the algorithm because it's generating the puzzle. First, we need a data structure. Please note that we have the data structure challenge here, and it's serializable and deserializable. There is a multitude of options how you can communicate between JavaScript and Rust. You can JSON serialize things. You can directly access objects in Rust memory from JavaScript. You can directly access JavaScript objects from Rust. You can have shared memory arrays, unsigned 16, unsigned 32, or float arrays where you can read and write from JavaScript and read and write from Rust. You can have a lot of different possibilities. I only have 30 minutes, and at the end, I will give you some additional links that you can use to dive into the topic of different variants of parameter passing if you want. But I think you get the idea just by looking at the code, right? It's the calculated formula in string representation and the calculated result, which is an integer value. Now, the code itself, I will not go into the details. I will just pick out some very special things. This is, for instance, an array, as you can see it here in Rust. Arrays are completely different from what you know from JavaScript arrays. Arrays must have a compile time fixed length, and it cannot change. This is what arrays are. If you want to have something similar to a JavaScript array, you would use a vector, the data type vec. Okay, the data type vec. This would come close to what you know from a JavaScript array. It's not the same, but you can push things into it and you can access with index and things like that. Now you see some interesting control constructs here. You see a for loop, for instance. Another thing that I can point out in Rust, all the variables are by default immutable, deeply immutable. If you want to have a variable to be mutable, then you have to explicitly say this variable must be mutable. Otherwise, you cannot assign a different value to it. What else do we have? Well, here we have a random number generator. This is a range. You might know that from other programming languages. What else do we have here? Let me see. You have, again, this match statement, which is kind of interesting. You can use some pattern magic here. This is a format string. In TypeScript, this would be the backtick with a $sign in it. You probably know that. There is a multitude of options how you can add and reference the parameters that you want to do here. So in this case, I'm just using some number, then an operator, a number, an operator, a number, an operator. I think you get the idea. Yeah. Then we check the length. The length must always be 7, so pretty simple here. But now comes something which is pretty powerful. Okay, so here you can see I created a function inside a function. This is a nested function, absolutely no problem, works perfectly fine. But the magic here is that here we are calling the calculate method from the operator that I showed you before. And if you remember back what we did here, the operator calculate can return either okay with a result, but it can also return an error if we have a division with a remainder. Can you remember? This is what we have to deal here with. And the beautiful thing in Rust is that if you call such a method, you can see it here, you can simply append a question mark. This question mark will recognize if the calculate method returned an error, and it will automatically propagate this error to the caller of this calculate method. So we do not need an if statement here. This is called error propagation, and it comes in super handy. Once you are used to it, you really don't want to give it away anytime soon. So this is really powerful. Okay, this is I don't want to go into the details how I do the calculation. If you are interested in it, it works. You can dive in it. We just want to take a glimpse of code into Rust. Okay. Now, what else do we have? Here we are just checking. This might be an interesting one. This is the idiomatic way of checking whether the result, which is a number, is between 0 and inclusive 99. What you essentially do is you are setting up a range, you call the contains method, and then you pass in a so-called borrowed reference to the result. This looks a pretty complicated way of checking whether a number is between 0 and 100 excluding or 99 including. Okay, so the beautiful thing of Rust here is if you use some things like iterator, and technically this is an iterator because what we get back here is an iterator, and we are using a method on top of an iterator to verify whether the number is in the numbers 0, 1, 2, 3, 4, 5, 6, 7, 9. This is the mental model what we are doing here. But in Rust, we have a very important motto, and this motto is zero cost abstractions. Although you are using conceptually an iterator, also if you do things like sum or map or filter, things you know from JavaScript, even if you do things like that, Rust will not give you the performance overhead. It will recognize these things and it will optimize it down to the most optimal assembler, in this case WebAssembly code. So this will result in very optimized comparisons. This will not do at runtime any kind of iterator magic or maybe even some vtable calls and things like that. That's the idea of Rust. You express your application with very powerful abstractions, with iterators, with error propagation, with enums, with structs, with trait, but you do not pay for these abstractions at runtime because Rust will optimize away a lot of these things. And then comes in LLVM, the low-level virtual machine, and it will do additional optimizations on top of it. And then you will get really, really powerful code. Code that is as fast as C, and in many cases faster than C++. And definitely faster when it comes to number crunching than JavaScript, C#, Java, or whatever you want. And at the end, we take this data structure that we did, and we are using the serializer and deserializer to directly write that into an object in JavaScript world. Okay, this is what we are going to do here. Finally, I have written a unit test for that. Of course, as good developer citizens, we have to use a unit test for that. You see the test. And in this case, I'm just generating some challenges, and I verify the business rules. Length must be 7, result must be between 0 and 100, and the result must be the same as the evaluated formula. Here I'm using a third-party tool which is capable of evaluating strings. It's like the JavaScript eval functions. We pulled it in here, but please note that this is just a def dependency. So we do not pay the price for this dependency at runtime. This is just for testing. And I do that 100 times. So I generate 100 formulas and check whether they are correct, because we have a little bit of randomness in here. So it makes sense to do it often. Let's try it. And as you can see, we do not have any warnings anymore. We ran 4 tests. Everything is okay. 4 passed. So the Rust code is done. We now have a nerdle implementation of generating the puzzle. Now you'll wonder, okay, how can I consume that in TypeScript? And I only have, let's say, 5 minutes left or so, so it can't be complicated. It isn't. Let me show you that. So let's compile everything, Wasm pack build. And what we get, once the build is done, take only a few moments, it compiles everything. Come on. Compiling to Webassembly, by the way. The first time takes a while. Yeah. This is live, so this is not prepared. I can show you that again. If I run it again, it's pretty fast, as you can see. And now comes the interesting thing, because what we get when we compile this one with Wasm pack is that we are getting, at the end of the day, an NPM package, just an NPM package. And this NPM package, you can publish it on NPM if you want, but you can also reference the folder if you want. So here you see the WebAssembly file. You have some, as you can see it here, some helper code. This is some glue code, which makes it super, super easy to communicate with Rust. This is where code is generated for handling Rust's result and turning it into exceptions, or where the serialization and deserialization from Rust world into JavaScript objects happen. And these things are inside of this JavaScript code. It's auto-generated. You don't have to care for it. And what you additionally get is you get, as you can see here, the TypeScript type definitions. See it? You have the run method, we generated it, and the generate challenge method. That is also the one that we generated. So you get TypeScript type definitions, you get JavaScript that makes it simple to call, and you get a ready to consume NPM package. Now let's try it. I will not go into the details of the TypeScript code, because you all are probably TypeScript experts. Probably you are even better than I am, so I don't want to embarrass myself. By the way, big kudos for the TypeScript code and the CSS magic and all these things to Karin Huber, from my wife, and a mentor of the Coder Dojo Linz programming club for kids. And she prepared this example for programming with some junior coders for the Coder Dojo, and I sneaked in and took her CSS to make my result look beautiful. So I didn't invent the CSS. That's really up to her, and thank you very much here. I only added the Rust stuff here. So let me show you what we do here. The most important thing is this one. See? Here we have a dependency, a runtime dependency, onto the package folder. Here we have the package folder. This was generated by Rust, by Wasm pack. This is what we generated from our Rust code. Then we have a little bit of Webpack magic with TypeScript. You all know that. You can take a look in my sample code. And then I can take a look here, for instance, in index.ts. And this is how simple it is to call a method from Rust. Let me call in the .dot folder npm install in order to get all the different dependencies. So then this red squiggly stuff will go away. Let's open the board, I think it is. Let me see. Is it here? Is it here? Is it here? No, it's in the game. Sorry. Yes. Here you see, oops. Let's do it this way. Here you see, this is the call to Rust. See? This calls our method, and this method returns an object containing the formula and the result. Can you remember this one? This is exactly what we had here. See? So the Rust data structure reflects here in our game. This is the challenge. Okay, good. Let it run. npm start. This will spin up the Webpack dev server. So let's go here. Boom. And this is on our, see it here. And yes, I am cheating. Yeah. Here you see first, this is the result of our run method. And yes, I'm cheating because I'm printing the final result here. But I think you get the idea. Let's make it wrong first, okay? So let's write 98 plus 6 minus 87. Press enter. And as you can see, we are pretty good. We already guessed 5 elements and 2 are wrong. So now let's make it correct. So this is 98. I can also use the keyboard plus 5 minus 86 and then press enter and you see, yippee, we managed to do it. So the whole UI stuff, it's consciously very, very simple JavaScript. No framework, no Angular, no Vue. It's vanilla JS, nothing fancy. But the number crunching is completely done within Rust. And we call into Rust to generate the formula, the expression, and to calculate the result. We have unit tests for Rust running in Node.js, and then we have a beautiful UI just sitting on top of it, doing what JavaScript really makes best, and that is UI stuff, not number crunching. That's essentially what I wanted to show you. And if I take a look at the watch, I think I used 6 minutes more than we agreed on. We agreed on 30 minutes. I hope that is okay. And now we can take a few questions if you want. Martina.
Yeah, thank you so much for your presentation. I actually always love when it's more live coding than just like a huge slideshow. And actually, I do have a question as well. Or actually, I'm pretty impressed as well, since I am actually like running C++ in WebAssembly, and I'm always wondering why everyone is jumping so much on Rust to WebAssembly, and no one actually cares about C++ to WebAssembly. And actually, a question I always get asked, and maybe you can answer it as well, is why WebAssembly at the first place? So why should I ship my Rust application to the web? Yep. Why should I care about that? And of course, does Rust shipping to WebAssembly and to the web browser finally replace JavaScript? These are always 2 questions I got asked as well. So I want to hear your answer to that.
I can give you my 2 cents on both. The first one, why should I care for WebAssembly? Now, first, you have to understand, or everybody has to understand, that WebAssembly is not just about the browser. WebAssembly, it's neither assembler code, nor is it code in the browser, so in the web browser. That's not WebAssembly. WebAssembly means that you get non-trusted or semi-trusted code from the web, and you want to execute it securely and efficiently on your machine without having to be afraid of security issues. If you have code in C or C++ and you download this code from the internet, you have to trust the developer that they don't misuse their power, because they can do whatever they want when you run their C or C++ code. But if I compile my Rust code to WebAssembly, and you take the WebAssembly and run it, for instance, inside the browser, or in Deno, or in Node.js inside the WebAssembly runtime, you're running the code essentially with assembler speed, but inside of a sandbox. So the code cannot do harm to your computer, because if we run it in the browser, it's protected by the browser. If you run it outside of the browser, it's protected by the WebAssembly runtime, which is embedded, for instance, in Node. So this is essentially it. You get the performance of assembler. You get the possibility to compile anything down to WebAssembly, not just JavaScript. So you get additional languages. And you can safely ship this code to any device. Can be a server, so you run WebAssembly on the server to execute some code there, Or on a desktop PC, maybe we will see some native WebAssembly apps that you can just double click in Windows and it will magically execute. And you can also do it inside the browser. So this is the first answer why, as a Rust developer or C developer or C++ developer, you should really care for WebAssembly. It gives your customers control and security. And the second question, will Rust replace JavaScript? No, absolutely not. What WebAssembly did is it broke the monopoly of JavaScript in the browser. This is what WebAssembly definitely did. So in the past, if you wanted to write code for the browser, you had to do it in JavaScript. Granted, you can use a cross-compiler, some kind of transpiler that compiles TypeScript into JavaScript or C into JavaScript, ASM.js. Can you remember the times that we had it? You can do that, but at the end of the day, it always came down to JavaScript. And with WebAssembly, that's no longer the case. Whatever you have, if you can compile it down to WebAssembly, it will run in the browser. So you have the choice to combine things. But the WebAssembly standard is pretty limited inside of the browser. For instance, as of today, you cannot directly access the DOM. You cannot directly make a web request. So WebAssembly can just manipulate bits and bytes in memory. And then you need JavaScript in order to communicate with the outside world, to manipulate the DOM, to send something over the wire and things like that. Will that change? Well, it's already changing more and more. And will we have WebAssembly only apps at some point in the future? Definitely. I'm strong believing that. So there will be a life without JavaScript if you want it, but you don't need to. If you like JavaScript and you just want something like Rust for compute-intensive stuff, hey, feel free to mix them. Better together, not replacing. That's the message that I want to bring across.
Absolutely. Yeah, that's also my opinion. Thank you so much. We have actually 2 questions from Julian in the chat. The first one is, here you focused mostly on the collaboration of Rust and JavaScript, but what top use cases do you see for Rust?
2 things. First, if you have an investment in Rust, for instance, if you build some medical software and you invested a lot in Rust for some visualizations of maybe X-ray data or whatever you want, then it makes absolute sense to take this existing code or existing code fragments if you additionally want to add a browser frontend. We already heard about the use case in the first talk where Adobe is using parts of their code base in order to bring parts of Photoshop into the browser. It's not a question of whether they are not wanting to run it in JavaScript. It's simply existing code. So for all the companies that are, as of today, investing a lot in Rust, and believe me, a lot of companies are doing that, it's a way of reusing existing code and still bringing this code into the browser. That's the first reason why you should care for Rust. If you don't have an existing investment in Rust and you ask yourself, should I do it? Well, the answer is, it depends. If you just want to do web development and your applications are mainly web requests, data binding, DOM manipulation, and that's it, you probably don't need Rust. It's not a big thing. Stay with TypeScript, stay with JavaScript, it's perfectly fine. However, if you want to do some really heavy calculation stuff, maybe some crypto stuff, maybe some rendering stuff, maybe some game or visualization stuff, maybe some physical or mathematical calculations, then WebAssembly is simply faster than JavaScript. But do test. It's not given that WebAssembly is always faster than JavaScript. If you have a lot of jumping around between JavaScript and WebAssembly, you might lose so much time for this communication thing that at the end, you are slower than just writing JavaScript. So you really have to test it. But in general, if you have to do a lot of calculation on the client side, then WebAssembly typically shines.
Absolutely. And I like to second that in a sense that with WebAssembly, you even have the possibility to use all the other third-party libraries from all other languages that can be compiled to WebAssembly.
Absolutely.
So for instance, C++ is really has a lot of like 3D rendering image recognition libraries, and you can just port them to WebAssembly and use them because there might be no such NPM package out there in the JavaScript ecosystem. So you can take advantage from all the other ecosystems around all the other languages. So this is also a great advantage.
Absolutely. Can I add something here? In the recent versions of Blazor, for instance, that's Microsoft's implementation of WebAssembly from .NET. So if you want to write web applications in C# and .NET, you can do that, and they compile it down to WebAssembly. They, for instance, added interoperability between C# WebAssembly and other languages like Rust. So what you can now build as of today, you can build an application easily that consists of C# things, a little bit of Rust things, and a little bit of JavaScript, HTML, CSS, and so on. You might think, well, that's Frankenstein, right? Nobody wants to do that. But believe me, yes, a lot of people want to do that. They have an existing investment in C# that they cannot throw away. They maybe want to add the compute-heavy stuff in the future in Rust. And they also have an existing investment in JavaScript because they maybe took a look at Angular or Vue or whatever, and now they simply cannot afford to rewrite everything in a single language. So they have to, at least over a certain period of time, go through a transition where it is super important to be able to connect things, and WebAssembly is able to do that. It's able to bring together pretty different programming environments in a single environment. It's maybe not the most efficient execution if you mix and match things like that, but sometimes you simply have to go for it in order to do a transition over multiple months or years.
That's super interesting. I didn't know that about Blazor yet. It sounds scary, but also really powerful, I guess, on the other side. Great. So Julian has actually another question. I guess you answered it already a bit, but let me read it to you. Could you name 2 major advantages Rust has from your point of view as opposed to other programming languages?
Only 2?
The result, of course.
Can I have 20? Okay, the 2 most important ones. The first one is obvious. Believe it or not, Rust doesn't have a garbage collector. Again, Rust doesn't have a garbage collector, but still you write memory safe applications which are more memory safe than most managed languages. And that's the magic sauce of Rust. This is why Rust has become so popular. It's super fast because it can produce safe, mathematically proven safe code, which does not have memory leaks, which does not have use after free problems, which does not have double free problems. Martina, you know this from C, C++, and so on. That's really an issue in that area. So memory safety without a garbage collector, this is number 1 if you ask me about Rust. The second thing that I love about Rust is the power of the language, the expressiveness of the language. If you dive deeper into Rust, you find so many gold nuggets inside of the language. I just showed you a little glimpse of it. You have seen traits today. You have seen error propagation today. You have seen pattern matching in the match statement today. We could talk for hours about these things. Macros, they are essentially a way of meta-programming. So you can build a domain-specific language with Rust macros that you can use inside of your Rust programs. Oh, this was already the third one, and I could go on and on and on. So this was just a few of them. So Rust is really a very interesting language, if you ask me, just from a language point of view, definitely.
Yeah, that's quite funny, actually. So my boyfriend right now, he's starting a new work, and he's learning right now Rust, and he coming from a C# background, and like it's every hour he jumps at me, oh my gosh, I learned something great at Rust. It's so much better than C++ and C#. So look at it, this is so cool. Here you have this result and the error handling, it's so crazy. And it's kind of drives me crazy, but it is definitely a really, really interesting language.
Yes, it is. Yes, it is.
So,
I really enjoy it very much.
So thank you so much, Rainer. Actually, you brought us another conference. Maybe you like to have a few words about the
Absolutely.
Global Azure
I would
Day.
like to invite you to 2 events. First, the Global Azure.at. Global Azure is for all of you who are interested in cloud computing, in particular Microsoft Azure. It will be on May 6th. It will be a virtual conference. It's completely community driven. It's completely for the community. It's for free for everybody. We already have a pretty astonishing lineup of speakers. So check out the website. And if you have time and if you find something interesting, we would love to welcome you there. That's the first thing. And the second thing, I am one of the co-founders of the Rust Linz meetup. So we do a monthly virtual, thank you very much, Martina. We do a monthly virtual meetup. Also, of course, for free, all about Rust. Every month we have some guest speakers or maybe local speakers. We are very beginner friendly. So even if you are learning Rust and you want to get some new ideas or pointers to some great crates or packages, then this is exactly what might be interesting for you. So both things are community driven. They are for free. So if you want to take a look, we would love to see you there.
Yeah, thank you so much. It's always great to have you. Actually, you're a really great speaker and really enthusiastic and passionate about your topic. And it's really, really lovely to hear you talking.
Thank you.
So thank you very much for being here. If you still have any kind of question, thank you. If you have any kind of question, reach out. I posted his Twitter handle over there. I guess his DMs is always open for any kind of question, and meet him at the Linz meetup. And thank you so much, Rainer, for being here. So give him a warm applause on the chat, and hope I see you soon again, Rainer. Bye-bye.
Thank you very much. Thank you for having me.